Okay, let's take a 3 by 3 matrix now and talk about what it means to find the determinant of this matrix. The determinant of a 3 by 3 matrix is defined, the determinant of A here is going to be defined like this. It's the number A, so just the number in this position here, times the determinant of the 2 by 2 matrix made up of the components E, F, H, K, minus the number B, so the number in different color here, the number in this position, so that entry of the matrix, that number times the matrix, times the determinant of the matrix made up of the components D, F, G, K. And then we're going to add the number C, so now we're looking at this entry, times the determinant of the matrix made up of the entries D, E, G, and H. There is an easier way to talk about these, and I'll show you the shortcut. This isn't really the definition either, but we do know how to find these determinants now because those are all the determinants of 2 by 2 matrices. So I'm going to simplify this by a step here. I'm going to say that this is equal to A times this product minus this product. So I'm going to have EK minus FH. That's going to be minus B times DK minus FG. And that will be plus C times DH minus E. What's going on with my pen? EG. Okay. Now these are all just numbers, right? E times K is just this number times this number. Use a different color here. That's E times K. That's just a number, right? So I can take this expression and I can distribute that number A through. So I'm going to get AEK minus AFH minus BDK plus BFG plus CDH minus CEG. That is the definition of the determinant of a 3 by 3 matrix whose entries are A, B, C, D, E, F, and G, H, K. Now, this first line up here is really already, I've already shown you how to take the determinant of a 3 by 3 matrix, but I'm actually going to do a specific example now so that we can walk through the steps doing the computations, and I'll show you some sort of insider tips and tricks. Let's take a matrix. I'm going to call this one C. And I want you to notice that I've used entries here that are all pretty small, and that's intentional. I want my arithmetic to be here, to be very simple, because the point is not to make a difficult problem, but to show you how something like this works. So the matrices that you may end up working with could have any number of nasty values in their entries, right? The entries could be any number of possible real numbers. But for this example, I've chosen a matrix with very small entries just so that we don't have any difficulty with the arithmetic. So if that's my matrix C, then the determinant of C is going to be, and here's where the tips and tricks come in. I'm going to start with, I think I'm going to do this in 3 different colors. I'll start with this pink here. I'm going to take this top row and the first column, and I'm going to note, first of all, the entry that's in the position where those 2 highlighter lines cross. So that's going to be this 1 right here. I'm going to write that down here. And then I'm also going to make a note of the entries that didn't get crossed out at all, these 4 right here. And notice that that is kind of like a sub-matrix almost. So I'm going to write 1 times the determinant of the matrix 1, -2, 2, 3. Now, once you've done this a few times, you don't need all of these steps, but I'm just going to go ahead and write them in this time anyway to be actually absolutely sure that we don't forget anything. My next entry, or the next term in my computation, I'm going to do the same thing, but this time I'm going to cross out the first, sorry, I'm having trouble getting the right highlighter here, the first row and the second column. So now I'm looking at a blue crossed out row and a blue crossed out column, and I'm going to note, let's see, I'll use the blue pen. I'll note the number first, that's a 1. And then this one's a little bit trickier. I have to note the numbers that did not get crossed out either in the row or the column. And that in this case is these two numbers and these two numbers. Those did not get crossed out by my blue highlighter. And so I'm going to write that determinant. It's 2, -2, -1, and 3. Oops, I forgot my determinant bars there. Okay, so there's the second term in this expression, in this computation. And the third one will come from crossing out the first row and crossing out the third column. First of all, I'm going to notice which term got, or which number got crossed out by both of those, and that's -1. And then I'm going to multiply that by the determinant of the numbers that didn't get crossed out by either of my yellow highlighters, and so that is these 4 numbers here, and that's 2, 1, -1, 2, and again, I forgot my vertical bars there. And then this is very important. These terms are in order: positive, negative, and positive. So I'm actually going to write a negative or a minus here and a positive here. And this is a little bit redundant because I have that -1 in front. I could have gotten away with not writing that, but just to be absolutely clear, it's critical that we remember that these terms have these signs. Okay, so now I'm going to do the actual computation, or the rest of the computation. So I'm going to get this 1, this leading 1, times the determinant of the 2 by 2 matrix inside here. So 3 minus -4. 3 plus 4 is 7. Then I'm going to subtract 1 times 6 minus 2, or 4. And then I'm going to add -1 times 4 minus -1, or 4 plus 1, and that's 5. That's going to give me 7 minus 4, which is 3, minus 5, which is -2. So the determinant of this 3 by 3 matrix is -2. Now, your textbook uses a different notation for the definition of a 3 by 3 matrix, the determinant of a 3 by 3 matrix, and so I'm going to go about here explaining where that formula comes from. It's based just on what we did on the previous screen, but here I'm going to use the notation that the book does. One of the reasons that's handy is that I can tell by looking at an entry here, just pick this one by way of example. If you take this out of its matrix, this number right here using this notation tells me that it came from the first row, third column. So it's quite handy notation in that regard. And if you find yourself ever needing to compute the determinant of, say, a 9 by 9 matrix, you're going to run out of letters very quickly if you use the A through K version of the problem or the example that I did on the previous screen. This notation is much more telling. It's much more informative. It's a little bit harder to write. It's a little bit harder to track, but it's much more informative. So we're going to go with that. And I'm just going to compute the determinant of this matrix. Let's see, I think I'll start here. The determinant of A is equal to, and if you'll remember, the way we did that was to take this is going to get a little messy again, but I think I'm just going to go for it. The first row and the first column. And the first thing I note is which value got crossed out by both of those, and that is A11. And then I'm going to take the determinant of the things that did not get crossed out. So that's A22, A23, and so on. I'll do one more. The second one is what happens when you cross out the first row and the second column. What gets crossed out by both of those is A12, and we want to multiply that by the determinant of what's left. Let me use a different color here. I'll use yellow. And what's left, the things that did not get crossed out by my yellow highlighter, are those values there, which are A21, A23, A31, and A33. And I might as well just finish it now that I'm here. The last term in this determinant is going to be determined by those two columns. What got crossed out by both of those blue highlighters was A13. I'm not going to have room to do that here, so I think I'll move that down here. And I'm going to multiply that by the determinant of everything that did not get crossed out by the blue highlighters, which is the things in this blue circle square. Those entries there. And those are A21, A22, A31, and A32. When I compute those determinants, I get A11 times, I'm going to compute this determinant now, I'm going to do this, multiply these two values and subtract the product of those two values. So I'll get A22 times A33 minus A23 times A32. Oh, there's something I forgot. I left it out on purpose initially, but I forgot to go back and add it back in. My first term is positive, my second term is negative, my third term is positive. So to this expression here, I need to subtract from that A12 times the determinant here, which is A21 times A33 minus A23 times A31, and to that I'm going to add A13 times A21 times A32 minus A22 times A31. If I now distribute, I get A11 times A22 times A33 minus A11 times A23 times A32 minus, because of this minus right here, A12 times A21 times A33 plus, again, I'm distributing a negative here, A12 times A33. I'm going to run out of room, so I'm going to take the whole thing and shove it over just a little bit. A12 times A33 times A31, and to that I'm going to add A13, A21, A32 minus A13, A22, A33. Oops, sorry, A31. A31. And that's the definition of the determinant of a 3 by 3 matrix with those components. Right, A11, A12, and so on. Your book has these in a different order, but that's all it is. Let's see, they've got A11, A22, A33, and the next term they have is plus A12, A23, A31. But that is just this term. Where is it? It's this one right here, but I made a mistake. I copied this A23 down as A33. So let me get in there and fix that real quick. That should be a 2-3. And that term there is just this term here, or I should say this one here is just this one here. And so they're just in a different order. Let's get the other ones. The next one your textbook has is plus A13, A21, 13, A21, and A32. And that is, this term here is A13, A21, A2, that's this one here. Addition is commutative, so I can write these terms in any order that I want. I'll take, notice that those ones are all positive, and I think the reason they've done that is because they like the leading terms, the first terms to be positive, or possibly they're making the observation that the first term goes in order 1, 1, 1, 2, and then 1, 3. Sorry, the first factor in each term. And then the other two factors in those terms use the 2, the 1, the 2, and the 3. And I'm not really sure. I'm not really sure why they've put it in this order. I think it's vaguely interesting that they have, but it's really not terribly important. So just as a matter of interest, I'll rewrite the rest of this. The last 3 terms are subtracted, and those are just coming from, let's see, the first one is A13, A22, this one here. So that's going to be next. A13, A22, and A31. And then the next one is A11, A23. This one right here. A11, A23, A32. And that leaves A12, A21, A33. And that's also a negative. So the definition given in the textbook is just given in a slightly different order. On the next screen, which is the last screen, you'll be pleased to know, I'm going to do another example of a 3x3 matrix, the determinant of a 3x3 matrix, and I'm going to use that example as a way to show you another approach, another way to do this. So I'm going to do that determinant in 2 different ways. The way we've done it before, the way you're seeing here, and the way we did it last on the previous screen. I'll do it that way first, but then I'm going to show you a different way to do the same thing. Okay, here's a 3x3 matrix D, and I'm going to look for its determinant. So I want the determinant D, and I know that's going to be -5 times the determinant of this matrix minus -2 times the determinant of, I'll have to use a different color here, but the determinant of the matrix made up of these 4 numbers. It's going to go in the yellow. And then I'm going to add to that +2 times the determinant of, let's see, I'll go with pink, these 4 numbers. Okay, let's see. I can do that kind of on the fly, and that's what I'm going to do this time. I haven't done it this way before, but I'm going to do it that way this time. I'm going to take this -5, and I'm going to multiply it by the determinant of the matrix you see here. And that's going to mean multiplying those 2 numbers to get -25 and subtracting this product here. That's 4. And then I'll do the same for the others. I'm going to take, let's see, which one did I do next? The -2. And I'm going to multiply that by the product of -2 with 5. That's -10. And from that, I'm going to subtract the product of +2 with -2, so -4. So I'm adding to -10, I'm sorry, subtracting from -10, -4. So that means I'm adding 4. And then lastly, I'm going to take the 2, I should have used pink there, let's change that. This 2 with the determinant of the values found in this cluster of 4 numbers there, and that's -2 times 2, which is -4, and -5 times -2, which is 10, and I'm going to subtract those. So that gives me -5 times -29 plus 2, because it's the opposite of the negative, times negative 10 plus 4 is negative 6, plus 2 times negative 14. And I'm just going to go grab a calculator and come back with the arithmetic result here. Okay, that turns out to be 105. So the determinant of matrix D is 105. And we got that doing the same thing as we've done all along here. We just took the first row and the first column, grabbed the number that got crossed out in both cases, and the matrix, the little submatrix down here that did not get crossed out by either of those lines, and put that determinant here, and so on. That's how we did it. And that's how we've done that so far. That's how we've done it on the previous 2 screens. But now I'm going to do the same thing using a different method. I'm going to take the same matrix, write that out here, negative 2, negative 5, and 2, negative 2, 2, and that's a 5, positive 5. And this time, instead of crossing out rows and columns and whatnot, I'm going to actually augment this matrix with its own first 2 rows. So I have, first 2 columns. So I have negative 5, negative 2, and negative 2, and then negative 2, negative 5, and 2. And I'm going to look at some, let me draw these out first of all. I'm going to look at the numbers in this diagonal and this diagonal. Can you see now why I augmented this matrix? And this diagonal. And I'm going to do that, and then I'm going to come back and look at a couple of other diagonals. But let's look at this one first. What I want to do with the numbers that you see highlighted here in each diagonal is I'm going to multiply them. So I'm going to have negative 5 times negative 5 times 5, which is a 125. Then I'll do the same thing for the other 2 diagonals. Negative 2 times negative 2 is 8. And 2 times negative 2 times positive 2 is negative 8. And then I'm going to add these up. So let's just do this, and I get 125. All right, now that I've done that, I'm going to do the diagonals going this way. I've seen this approached a couple of different ways. You can either think of going down the diagonal like this, or up the diagonal like this. It really doesn't matter because, again, you're just going to take the product of these numbers. So let me get rid of those arrows. Maybe I'll put them at the top. Let's see, I get negative 2 times negative 5 times positive 2, which is 20. And then 2 times negative 5, that's 4 times negative 5, that's negative 20. And 5 times negative 2 times negative 4 is, again, positive 20. So these add up to 20. There's already a minus here. If I add that, then I get 20. So I have this 20 and I have the 125. And what I'm going to do is take the result of these diagonals, call it positive, and the result of these diagonals and call it negative, and add them together. So I'm going to get 125 minus 20, which is 105. So depending on how you like to think, this approach may be easier for you. The other approach may make more sense, in which case you're more than welcome to do it that way. You get the same result, as you can see, from doing it either way. And I'm happy to entertain both of those approaches. They're both quite commonly used, and they both return the same result. So it really doesn't matter which one you use. At some point in the near future, if I get a chance, I will make another video showing this method. But I think you'll find that there are a lot of sort of YouTube videos and other resources out there that show you how to do, how to find the determinant of a matrix, a 3x3 matrix specifically, both ways. And equally, you're welcome to use the formula if you prefer that. So that is how we find the determinant of a 2x2 matrix and of a 3x3 matrix.